So we discussed the definition of percentages. So this is the formula for this. Then we did fraction to decimal to percentage conversions. This is a direct formula that comes X percentage of Y problem. We talked about that. This is the intermediate problem, in successive increase and decrease. Again, repeating, multiply things, not add and subtract them. And then we defined what is the reverse percentage problem. When the number is unknown and you know the percentage on the final number, you can take the number and divide that by this. 40% is what in decimal is 0.4. So you convert that into decimal and divide that, and that will give you the number. So these are the 4 main categories of problems we have covered so far. Let's move on to the 5th category. Now, these are indirectly, you will not realize that these are percentage problems, but in order to solve this class of problems, you have to use ideas from percentages. Okay, so that's what you are doing. And these are like discount, profit loss, simple interest formulas that are asked on different things. Now, in order for you to solve this problem, you need to understand different terminology first of all. So let's explain what those terminologies are. In this equations, right, we are rewriting a lot of things in short. So let me expand upon all of this. So when you go to shop, right, and when you take a piece of clothing or something that you're shopping for, it has a marked price. Okay, so MP is known as marked price. Sometimes the items do not sell at the marked price. There is a discount on it, or you add tax on it. So you have to pay something which is different than the marked price. So if you're paying tax on it, let's say 8%, so you're paying 8% extra on the marked price. If there is a discount, then the marked price is reduced and you get to what is known as sales price. SP is for sales price. Okay, so anything that is written here as is sales, M is marked. Okay, so if you know what is the marked price and what is the sales price, then you can compute the discount. Or if you know the discount and if the marked price is known, then you can use this equation to find out the value of the sales price, right? So that's why we are writing these equations that is here, which basically correlates 3 terms: marked price, sales price, with the discount or off percentage that is here using the equation that is given here. Similarly, you can have a profit and loss equation. Okay. Now, profit and loss, in case of, just to understand the same analogy or same problem, when let's say a store, they might be selling an item at a sales price, but their own cost of procuring that and bringing that item in the store typically will be lower than the sales price. So the price at which they are procuring it or they are getting the item is called cost price. This is what the store has paid to someone else to get that item in the store, but they are selling to you at a higher price, which is the sales price. So this is sales price. The cost price is the cost to the store to buy that object. So the profit or loss that store is going to make will be determined by this overall equation. So you subtract the cost price from the sales price and divide the overall thing by cost price and multiply that by 100, and that will give you the profit or loss the store will be making on that item. Okay, so what I'm trying to do here, I'm trying to explain different commerce terms. Okay, and that is also needed. But essentially, if the calculation you are seeing, they are percentage calculation. But in order to solve this, you need to have a notion and understanding of what could be marked price, what could be sales price, what could be the cost price. And that is what we have described here. So marked price is the thing that is marked on the ticket. Sales price is price after discount or price after tax. Cost price is the cost that the store has paid to procure that item before it sells it to you. Okay, so those are the terms we have explained. Now, interest also is there. So interest problems also comes. So one problem, the simple interest problem is whatever is the principal, right? And whatever is the rate and whatever is the time. So if you are calculating that if I borrowed $100 with the interest rate of 10% for 2 years, then how much interest will I end up paying for it? Then that equation will be given by this equation, 100 times 0.1, because 10%, and times 2, that will give me calculate the interest I need to pay on the principal amount. You also probably know what happens in the compound interest case. So the compound interest case is a complicated version of simple interest. And what is happening here is instead of having a fixed amount of interest on the thing, what we are doing is like, let's say we have $100. And after 1 year, if we took 10% interest on it, then we have to pay additional $10. So now the principal become $110. So the next years, we will be calculating the interest on $110, not on $100. So this is where we're adding up the accrued interest on top of the principal. And this process, when we compute it, is known as compound interest formula. And in case of the compound interest formula, if you want to calculate the interest, compound interest, then that is given by this equation where you have P, and in the parenthesis, we have 1 plus R divided by 100 and to the power T minus P. What was the initial? So this is 100. And if this was 10, right? 1 plus 0.1. Let me actually explain what is happening with an example so that this becomes clear, okay? So let's say P was 100, okay? And rate was 10%. And time was 2 years. Or 2 years just for the simplicity case so that we can easily do that. So the simple interest will be calculated using this formula. So in this setting, when we are using this formula right here, I can write and calculate the simple interest, and I will write that as a short as a SI. Simple interest is $100. Now we have to convert this percentage into decimal. So 10% into decimal is 0.1. So this rate will be 0.1, time is 2. Okay, that will be the overall equation that we are doing, right? If you are using this one, right, we can substitute the 100 itself, right? So let me write in this terms. So dollar principal is 100, but now we are substituting this 10 as interest, and this is divided by 100. So that's why this 100 is coming into picture, okay? Times, makes sense? So that's, I'm trying to correlate why this 100 is there. So in this setting, R is 10. But R by 10, you can directly convert into 0.1 and you can use this formula. Or if you want to use this, in this setting, you are using the R percentage value. So what is the value here? So if you calculate this, this is going to be $20. So you are paying $20 interest, simple interest, if the initial principal is $100 and the interest rate is 10% or in decimal 0.1. But in case of compound interest, this will be the equation that we'll be using. So let's use this equation. So this is P is 100, 1 plus R, R is 10, still the 10, 10 divided by 100, 2, because time is 2 years, minus 100. That will be the compound interest, right? So let's write this by this abbreviated thing, which is CI, or CI is called compound interest. Here, SI, simple interest. This is CI, compound interest, okay? So let's calculate this now. So again, this will be 100, and then this will become 1.1, 100. Okay, how we are getting 0.1? 1 divided by 10, that's 0.1. We add that to 1, this will get how? But this will be squared, right? So what is 1.1 square? 1.1 square is 1.21, right? You can use a calculator to do it, right? But I know the square of 11, so I can just do this way. And this is 100. Okay, so if you subtract this, this will become now after multiplication, this will become 121, and this will become 100, and this will become $21. So the compound interest using the same principal and rate is $21, but using the simple interest, that is $20. So the compound interest is always more than the simple interest because you're charging interest on top of interest in the successive years, and that is why the terminology compound comes into the picture, and you get this equations that we have. So you need to remember all of these equations, right? Compound interest equations in order to solve the problems faster. Okay, so hopefully you got the idea about sales price, cost price, marked price, compound interest, and simple interest, and the equations and the formulas related to them in this overall slide. Okay, now once you know the definition of what is compound interest and other things, right, The profit is basically sales price minus cost price. The loss is the cost price minus sales price if the cost price is more than the sales price. Profit percentage is profit divided by CP in times 100. Loss is loss, and profit and loss are computed by this. And the discount price is, or the discount percentage is maximum price minus sales price times M times 100. And those formulas are also listed here. So these are like some of the common formulas in commerce applications that is there. Discount, profit, loss, simple interest, compound, marked price, sales price, and cost price. These are the concepts that you need to know. So we discussed the most commonly occurring concepts that are coming on DSAT problems in terms of commerce application, but underlying that, the calculations are percentage-based calculations. So you're basically doing percentage solutions, solving using percentage. That's the machinery, mathematics machinery that you're using to solve the commerce application problems of discount, profit, loss, simple interest, and compound. So this is another variation where you're using the fundamental knowledge of percentage calculation to solve for this category of problem. Okay, so now let's move on. So this relates the concept of mark price, sales price, and cost price. You need to know all the three definitions to solve this problem. It's a medium hard, and you have to do two computations and then correlate those computations. So that's why it's taking a little bit more time. But we got one answer, and that answer is right. So good job. We got a second answer, but that answer is not right. And we will see how to solve this. Give you the clue. You can use this piece of information to find the sales price. Okay. Discount will give you the sales price. Okay. Now, cost price plus 25 increase on that is equal to sales price, right? So you can use, once you get the value of SP, you can use this part to find out the cost price. So that should be the approach that you can use to solve for this problem. Okay, let's go through the solution approach for this problem to solve this problem. Okay, the answer is B. Let's see how it comes. Okay, the sales price is 30% reduced on the marked price, right? So, again, whenever we are increasing or decreasing, what is the equation we are using? And that's what you need to get familiar with. 1 minus R by 100. This is the decrease, right? So discount or off is decrease, right? So 200 times decrease, which is the discount, where the R is 30. If we substitute that here, we will get this, right? 30 divided by 100, we can calculate that. This is 0.3. 1 minus 0.3 is going to be 0.7. 0.7 times 200 is going to be 104. So that will be the sales price. Okay, this was the sales price equal to mark price times the discount that we have, right? That's the equation we are writing. So that's the step one. So this is step one. In the step one, we determine the price of the sales price. Now let's go to the step two. Okay, so there is a profit on the cost, 25% profit on the cost price. So the sales price from this equation will be using this equation. So what we are going to be doing in the cost price, we have to add the profit, right? So in this setting, we'll be using this equation. But the value of R that is here is going to be 25%. Okay, so and this will become CP times 1.25. And that is going to be equal to the sales price. But we know already the sales price from here. So we'll substitute that sales price here. And now I can find out this by taking this and dividing this whole thing by 1.25, right? So this will be divided. And if you simplify this, this should come out to be 112. So that's how you get this overall solution.